after a long night, I've managed to hack together a functioning version of the Magentic-one agentic workflow for Microsoft that I made my previous video on. However, it is now using Ollama with the Meta Llama 3.2 11B vision model. So having the vision model there allows it to actually web browse kind of in the same way that it was doing in the Microsoft demonstration with the GPT-4o API endpoint. Except instead of being relatively expensive considering all the kind of back and forth that goes on with the AI, it's just for the cost of your electricity. So I'm going to kind of just show some of the scripts that I changed, quick demonstration, maybe show what still needs to be done because it's still not really perfect. There was a bit of kind of coaxing of the model that needed to be done in order to get some of the responses to be returned in the expected format. And yeah. All right, so before I talk a little more about this, I just want to kind of show the actual level of progress that I made here because it is not as good as the demonstration I showed in my previous video, of course, where it was using the GPT-4o API endpoint. And as probably one would expect, considering this is using the 11B vision model, Llama 3.2. So I am just going to go ahead and run the example script as I did in the actual demonstration I did a few days ago. And I'm going to give it sort of a web browsing task so I can kind of show you what it does, its strengths, its weaknesses, and things that I think the community can help me in making better because we all want to use this locally and without APIs. So, all right, so here's just sort of a random little thing saying, okay, I want you to browse the web, find a recipe for some big fluffy pancakes, and then describe it. Now, you can see here that first and foremost, it is actually functioning just using the Ollama LLM, which is freaking awesome in my opinion. I've honestly wanted something like this for so long, and seeing Magentic-one just was like, okay, this like we're here, we're almost there. So we can see the orchestrator functions, and it kind of delegates tasks to the different agents as it did in the other demonstration I did. One thing I noticed about this is it really likes to implement the coder all the time, like write a Python script to scrape the HTML content. It literally seems to do that for like every web prompt that I put in. So make of that what you will. And we can see here now over in the logs folder that we're getting some screenshots. Now, I haven't done too much to change a lot of the architecture from this, but one thing I did do is change it from Bing to Google. And actually the reason I did that isn't to be like a hater or anything, but I was troubleshooting some issues I was having and I figured maybe it would be easier for it with Google. Yeah, that wasn't it, but I already did it, so. And now we can kind of see, so okay, you can see the orchestrator is delegating a task to the WebSurfer, browse the web and find a recipe for big fluffy pancakes. And then it's saying, okay, here's what I'm going to do. Here's a screenshot I'm basing off and things like that. And then I've had to, oh, no, go away. I've had to kind of modify some of the prompting in the WebSurfer agent because it was not properly returning things in a format that was expected to actually do anything. So it wasn't getting past the Google homepage, which was kind of an issue. And that took me an embarrassingly long time with much assistance from Claude and 4o preview. So, okay, we're down here. Okay, the web page timed out before completing the task. I don't know. And sometimes we see errors and things like this. But basically the whole point of this convoluted little demonstration I just gave is to show that it is actually able to browse the web and kind of do stuff. So as we look at these screenshots here, this is kind of what it's seeing. And these, I don't think they're called bounding boxes, but for some reason that's what came to mind. So it identifies the elements on the page, and then from that it can actually go about selecting which one to pick. So the actual functionality here, based on the fact that it is running totally locally off of the 11B vision model. I mean, if I could run the 90B, I would be ecstatic. But this is really exciting personally, for me, to be able to do this without incurring a large amount of expense with the API cost, because just playing with this the other day cost me about 70 cents, which relatively speaking is not a lot, but if you were going to consistently be playing with this, it would go on and on and on. And okay, so we can see here now we've gotten some issues and things like that, just some JSON return. Sorry, I'm kind of like not able to fully extrapolate my thoughts. But it actually did get to a web page and open it, and that is very exciting. I know you might be like, that's not exciting, but for those of us who are watching this and going to be playing with this ourselves, it is exciting. Now, the Llama model using Ollama, and you can see here that card 0, I think we can ignore the utilization of that, because when I wasn't running OBS, that was just like at like 200 megabytes or something like that. Card 1 is holding it, and it's using about 11.6 gigabytes of video RAM. I have seen people say that you can run Llama 3.2 Vision 11B in like 8 gigabytes of VRAM, but I'm not seeing that here, but there may be some tricks and things like that. So basically, this is one thing to do. So, okay, so this one ended. I'm just gonna make sure that I'm in my terminal. So clear. And then I'll do one more, maybe something a little different. So all you do is run that, and I am using the save screenshots flag, which is actually outputting the screenshots here, because that was really important for me to actually be able to troubleshoot to see if it was actually going past the static homepage, which for like 7 hours it wasn't. So, so I will say, okay, so now we're trying a little more in-depth sort of thing. So I'm having it search the web to find a function to trade based off the moving average trade signal and write a simple script to try this. So this is going to perhaps add a little bit of complexity and pull in some other agents, hopefully. And let's see. So, and you can see here, all of this response here is coming from Llama 3.2 11B Vision. So to answer this request, we're the following team: the WebSurfer, the coder, the executor, and the file surfer. I have not actually used the file surfer yet, so I don't know if it'll work or anything. So facts to look up: definition of MVA trade signal. This might be found in financial literature such as Investopedia or Wikipedia. So this model already has some relatively decent knowledge for just playing with this on your own system locally and things like that. Okay, so we have the RSI and the MACD, or whatever the heck you call that. I don't know how to pronounce it. This might be derived, so it's giving it facts to derive, educated guesses. And here's our plan. So it gives us some bullet points. We've got our WebSurfer, coder, executor, and file server. So let's see. And you can see here that it's outputting things here, and this was actually just a debugging step I needed to do to kind of try to troubleshoot it. So if this looks a little different from how it looked in the actual demonstration that I did with the original repo and using GPT-4o, that's why. So let's see what it's up to. So it's doing web search. And here is, this will make sense in a little bit. It's actually outputting the code task execution that it needs to do in the WebSurfer task. That will, again, make sense in a little. And basically, I can go ahead and just kind of see what this thing's doing here. I don't know what this screenshot is. Okay, send feedback to Google. Okay, now, okay, so it seems to have been, got stuck. Let's see what it says about this. I'm actually happy that happened. I want to see how it, so I'm not quite sure what it's gone and done here, but if the orchestrator, okay, so I'm sorry, I was reading the wrong thing. So it's having the coder do stuff right now, and I found the coder is not really half bad for what you would think this model would be able to do, especially considering I don't think this is really specifically a model designed for coding. So this is a simplified example, and we can see here in the ledger, refine the script. So the coder's saying, I have some errors, let me re-examine it. And it's found some errors and things like that. Now, I'm probably not going to be able to actually test this code to see if it works, because I haven't actually tested the file agent and things like that. But I think this is really a fantastic demonstration to see that this is all just running locally. So it is really possible, someone more knowledgeable and spending more time to really mold this to function well with an open source model like the 3.2 Vision or 90B Vision if you got the big beefy cards. And we can see here that it's just kind of still going. It may be kind of in like a loop at this point, but okay, it seems like it's back in the web browser. So it's searched for MVA trade signal Python library. Let's see. Okay. And it comes up with some more. But again, I want to just kind of touch upon the fact that this would really be getting relatively pricey if this were running through the 4.0 API. So for people that even just want to play with this without actually needing it to do anything in terms of like a functionality standpoint, this is what you want, because I mean, it's using like 12 gigs of video RAM, and a lot of cards can do, I mean, anybody with a 3090 right now can basically play with this for the cost of electricity, which is, I'm not going to swear, but it's very awesome. It's very exciting. I'm really excited. I might seem like kind of tired, but I've I've been in front of the screen for north of like 13 hours. But okay, here's a screenshot of GitHub. So this thing's really going. And I'm going to be honest with you, is it actually... Now, it was hallucinating a lot before, where it was not even going on the web. It was just making things up. Some of them were quite funny. Okay, so it doesn't seem like it's on GitHub. I find that still one of the limitations of this is that it has trouble actually going past the search page. Well, okay, I'm probably going to stop this now and say that it wasn't quote-unquote successful. However, it works enough that, like I said, I think somebody with a lot more programming knowledge than I have can go in and actually just fix this and make it work perfectly, which is what I want. So basically, what I'm going to do is put this on GitHub. I'm very green with GitHub. I don't have really any experience using it, so I think the proper methodology is to fork the repository and just put up the scripts that I changed in addition to what was existing in the repository. But before I do that, or, well, I'm going to do that when you see this video, it'll be done, but I want to just kind of touch upon the main scripts that I changed here. Now, I had initially wanted to change the example script because I figured that might make sense, but I actually looked at how it was calling the AI, and I found that in the utility script, so if you go into source and, well, here's the full. Okay, so if you go into the directory here, basically you will see kind of the location of this utils.py. So that is one thing that I really had to play with. And simply what was done here is basically, instead of where it was just kind of set to use the OpenAI API and things like that, I just set it all to the Ollama server, which is localhost at port 11434. That was the model name, 3.2 Vision. Now I have not played with the temperature here. I wonder if letting the temperature go far lower would actually help it output more consistent structured JSON or things like that. However, this was just something I modified so that it was actually going to be able to communicate with Ollama on my local machine and things like that. It wasn't too bad, this one. The other one that I really had to do a lot of playing with was if you go into the agents folder in the multimodal WebSurfer, in the multimodal WebSurfer script. It's a long script, well, relatively speaking, depending on what sort of code base you're used to working on. So in here, I just kind of changed it to Google a lot, but there were some other places that needed to be changed in a few directories up. But one thing that I had to play with here, pardon me as I scroll down and find it. So these here, you can actually see, these are the tools it's using. So when it decides on like a tool to use, so like you can see here, it's using the click tool. And the ID is kind of how you saw the boxes here on the website. So each one of these has like a little ID number, so it'll actually specify that and hypothetically work. So like we can see, okay, there will be a click tool right here, and it tells it like, okay, here's the do, I clicked it, and then we'll output here. The thing that I really had to play with here, and something that I think will provide a lot of different malleability to the actual WebSurfer behavior, is this text prompt here. Now, the one that actually came in the repository was far simpler than this, and I had to really go and like guide the model's output. I was having a lot of problems with it where it was not returning a JSON object for the actual, what are these called? I'm sorry, I often find that I can't think of the word, but I know what I'm thinking of, but the word doesn't come to me, the execute tool. So that was something I was having problems with. And to actually help with that, I went, because the orchestrator script is actually also requiring the model to output JSON, and it was doing it like perfectly every time. So basically, every time you see this orchestrator thought with the ledger, I do believe this is a JSON output. Don't quote me on that, but I'm like 87% sure. So that allowed me to kind of troubleshoot more with the help of like Claude, obviously, and O1 Preview, how to get this to work. So yeah, that's probably like a really convoluted and rusty explanation, but basically I played a lot with this script here, and eventually it just kind of started working. So as you can kind of see here, it kind of works. And here we can go, I didn't really look at any of these because these were less interesting to me than actually having something that could autonomously browse the web, which is something I've been seeking for a very, very long time. Something that would be local and not linked to an API. We can see that the coder actually was outputting some code and things like that. I don't know if it was of any reasonable quality or anything like that. So, okay, we have pandas, we have NumPy, calculate the moving average. Okay, some simple like arithmetic, things like that. Let's see, does it? Okay, so it's telling me, okay, give me stock data. Okay, so reasonable. And again, this is like an early vision model, I think, that most people can actually run. Most people meaning people who have like a 3090. So in the local LLM scope, most people. So yeah, this is basically just my demonstration of this, and I wanted to just show how this was going. I suppose I should probably just quickly show how I am running Ollama, which is by far the simplest part of all this, because it's incredibly simple. So I'll do that, and then it's probably going to be it. I'll post a link to the fork of this that I make in the comments to this video, and hope that in the next few days somebody with much higher knowledge than I has gotten this working perfectly, so then I can go and use it for fun purposes. All right. Now I'm going to go over this in a very quick way because there's a lot of better documentation out there for Ollama and how to use it. In addition to that, it is rather simple and easy to use for beginners even. So really all you need to do to get this working with Ollama is just go to ollama.com and you would download it and follow the prompt there. But for my case, I'm using this Llama 3.2 Vision 11B. And if you want to go ahead and do this, all you have to do is copy this, paste it into your system terminal where Ollama is installed, which I already have it done, so I'm not going to do that. And then assuming you've done all that, basically all I did before actually testing all these scripts is do Ollama list to kind of show, okay, yes, it is here, modified size. And then Ollama serve, which was actually already running because it was listening on localhost at the default, I think, Ollama port, which is 11.434. and it's giving me an error because the address is already in use because it's already in use. So that's just a super quick, like crap explanation on the Ollama, but it is really quite simple, and Ollama is wonderful. It's easy to use, and there's a lot of good documentation out there if you have any questions on this specific aspect of it. Yeah, so that's the Ollama thing, and yeah, I'm interested to see if anyone can actually comment on having that model run within 8 gigabytes of video RAM, as I do believe I saw somewhere that it should have been possible. So cool.